Welcome to my channel V Concepts CHM. This is the second part of the series of Introduction to Optical Fiber, where we will study about the optical fiber and then we will see the necessity of cladding. In the last video, we had studied about the total internal reflection. The optical fiber is based on the principle of total internal reflection. So now we will see about the optical fiber. It is a thin flexible pipe made up of transparent hard glass or plastic. It can guide the light beam through it. That is, when a light beam enters into the optical fiber, it will pass through the optical fiber and it will come at the other end. This occurs because the light beam that enters into the fiber is completely internally reflected. Hence, the optical energy or the light energy gets trapped within the glass pipe. Hence, the optical fiber is acting like a waveguide for the light. Optical fiber is based on the principle of total internal reflection. You can see here, this blue pipe that you see is an optical fiber and the light ray is entering into the optical fiber. When it enters, it will undergo successive total internal reflections from the side walls, and that way it travels through the length of the fiber along a zigzag path. A small fraction of the light may escape through the side walls, but a major fraction emerges out from the exit end of the fiber. The light can travel through the fiber even if it is bent. Now we will see the structure of the optical fiber. So it is cylindrical in shape and it has generally three coaxial regions. First part of the optical fiber is called as a core. It is the innermost cylindrical region which guides light. Next is the cladding. It is the concentric middle layer surrounding the core. Note that the refractive index of the cladding is always less than that of the core. So that the condition for TIR is satisfied, which requires that there is a denser medium and a rarer medium, and the light will be passing from the denser to the rarer medium, and that time TIR can occur if the angle of incidence is greater than the critical angle. So the cladding actually serves to confine the light to the core. Third part is the sheath or the buffer coating. It is the outermost plastic layer. It is a protective layer. We can say it is a protective layer for the cladding. It is elastic in nature and prevents abrasions. In terms of diameter, we can show it in the form of a cross-sectional view. You can see the cross-sectional view. First we have the core whose diameter is between 8 micrometer to 62.5 micrometer. Next we have the cladding whose diameter is about 125 micrometer. And third is the sheath or the buffer coating whose diameter is between 250 to 900 micrometer. What is the necessity of a cladding? If If you don't have the cladding, that means it is a bare fiber. We have just only the core. Then the light entering a bare fiber will travel along the fiber through repeated total internal reflections at the glass air boundary. This kind of bare fiber is used in certain applications. But in communications, the optical fiber is to be used with additional precautions. And for that, the cladding will help. If the core is surrounded by the cladding, it will be much efficient communication system. So why it require it? The cladding maintains the uniform size of the fiber and it reduces the loss of light from the core into the surrounding air. As I said earlier, it satisfies the condition of TIR. The cladding is the rarer medium and the core is the denser medium. So light is completely, totally internally reflected. No light is refracted out into the cladding. It protects the fiber from physical damage and environmental parameters. It reduces the size of the cone of the light that will be trapped in the fiber. Thank you for watching this video.